Salzgitter AG is one of Europe's leading steel technology companies. It has long been involved in manufacturing heavy plate. And when it comes to delivering a variety of products for diverse applications, Ilsenburger Grobblech GmbH is at the center of attention. Salzgitter Steelworks, the biggest and most important supplier of slabs for Ilsenburg, produces more than 4 million tons of steel every year. In fact, steel of the highest quality is made here 365 days a year. The pig iron produced in 3 blast furnaces is delivered to the steelworks in torpedo ladles and desulfurized. In the Base oxygen converter, oxygen blasting oxidizes impurities and removes them from the pig iron, turning it into crude steel. During secondary metallurgy, the crude steel can then be adjusted for the analysis and temperature required by means of alloying, heating and vacuum treatment. Ilsenburger uses about half the 400 or so chemical compositions to make heavy plate. 3 advanced continuous casting machines are available to cast the liquid steel. Depending on the plate dimension required, the slabs are partitioned, adjusted and loaded for further processing following surface inspection. Ilsenburg is located on the northern edge of the Harz Mountains in Saxony-Anhalt, about 55 kilometers or 34 miles southeast of Salzgitter Flachstahl GmbH Steelworks. Every year, Ilsenburger rolls about 800,000 tons of heavy plate in all known grades, up to a maximum plate weight of 20.5 tons. The slabs produced in Salzgitter are delivered to Ilsenburg by rail. Following visual inspection, they enter the rolling program and are forwarded to the pusher furnaces on a pull-type skid conveyor. During handling, the size of each slab is checked by laser, while integrated scales are used to weigh them. The slabs are then pushed onto one of the 4 tracks of the 2 pusher furnaces using slab pushers. The slabs are transported through the furnaces on 2 skids per track. The stacks of slabs are pushed forward by the following slabs. The slabs undergo computer-controlled natural gas-fired heating. After spending about 4 hours in the furnace, the slabs are ready to be transferred to the rolling process. A discharging machine removes each slab and places it on the roller table. The heating process in the furnace and transport are monitored and controlled from a furnace control unit. The control unit also keeps tabs on 2 other heating furnaces, a bogey hearth furnace and a pit furnace. The descaling spray removes the scale formed on the slabs during heating in the furnace by spraying water through nozzles at a pressure of 200 bar. The rolling schedule is calculated during the transportation of the slabs to the roll stand from the following parameters: slab temperature and size, steel analysis, the rolling method selected, and the required size of the plate. 4-high rolling takes place as shown in this picture in the roll gap between 2 work rolls. The work rolls are positioned on backup rolls with double barrel diameter, enabling a rectangular profile to be produced in the plate. Ilsenburg produces plate with a thickness of between 5 and 120 mm and a width of 800 to 3500 mm. The two work rolls are powered by the main drive with an output of 2 times 6,400 kilowatts via a spindle system. The combined hydraulic and electromechanical screw down produces a maximum rolling force of up to 8,000 tons. The internally developed rolling schedule computer model is ideal for the production of plate with the tiniest thickness tolerances in terms of length and width. The thickness is measured in the middle and on both edges using isotope radiography. The dimension tolerances achieved on this extremely stiff roll stand set a new standard all over the world. After the rolling process, accelerated water cooling can be used to adjust the plate's mechanical and technological parameters. The ACC system is provided with data determined from the preceding rolling and other necessary parameters. The cooling model, which is the central module of a complex automation system, ensures the plate cooling process takes place completely automatically. Work is completed by a hot leveling process, hot marking on top and bottom, or stamping and a hot shear process if required. This is followed by cooling on cooling beds. Turning the plates over enables the visual inspection of both sides. Depending on the thickness, the plates are cooled in stacks before undergoing surface inspection. During cooling, the effusion of hydrogen from the plate takes place in order to prevent hydrogen-induced cracks. Ultrasonic testing is used to ensure the steel plate does not contain any internal defects. This is followed by customer marking complete with order data to identify the plate. In the shearing line, plate is trimmed down to a thickness of 40 mm and cut to length. Samples are taken to determine the plate's mechanical and technological parameters. For long-term marking, the steel plate can be stamped using the computer-controlled stamping carriage. Uneven plate and plate with internal stress undergoes cold straightening. Depending on plate thickness and the yield point, a straightening model calculates the optimum settings for the cold straightening machine. The broken and loose scale occurring during straightening is sucked off after the